Now let's see the definition of a circle and the equation of a circle. So a circle is a set of all points in the plane that are equally distant from a fixed point. Okay, now all of you know the shape of a circle, right? But now we're going to look at this mathematically. Okay, so it says that the fixed point around which the set of all points that are equally distant is called the center of the circle. So what that means is if you draw a coordinate axis, right, the y-axis and the x-axis, and let's say you pick this fixed point over here, right, and all of the points equally distant from this one point eventually make up a circle, right? Because this point over here is of the same length as this one, is the same length as this one, this one, this one, right? These are all the same lengths and they're all centered around this one point, which is the center of the circle, okay? Now, the distance from the center of a circle to any point on the circle is called the radius of the circle. So all of these distances that are drawn on the circle that are equally distant from the center, all of them are the radiuses of the circle, or the radii of the circle. Okay. Now, let's see how we can construct the equation of a circle. We say that, let's say that r is the radius of the circle, right? The distance from the center of the circle to any point on the circle. And let's say that c represents the center of the circle. So the coordinates, the x coordinate of the center is h and the y coordinate is k. Okay, these are just arbitrary coordinates. And let's say that the point P is any point on the circle. Okay, and obviously the x coordinate is x and the y coordinate is y. Okay, now let's just draw out what I mean over here. So this is the coordinate axis. Let's say this is the center of the circle. So this is the point C. Okay, this is the point C. And in the x-axis, it is at h, and in the y-axis, it is at k. Okay, and now let's draw a circle around it. And let's take any point on the circle. Let's say this point over here, right? Let's say this point is point P, right? And its x value is the x and its y value is y. Okay, now that you have all of this, we need to calculate the distance from C to P, and that will be the radius. So the distance from P to C is the radius r, and we already know that the coordinates of P are x and y, and we know that the coordinates of C are h and k. So the distance from P to C can be represented like this, right? You already know the distance formula from before, and that is equal to the radius r. Now, if you square on both the left-hand side and the right-hand side, you get this, right? And this is the equation of a circle in its standard form, by the way. And if the center of the circle is at the origin, so the x value is 0 and the y value is 0, right? The x value is 0 and the y value is 0, then this equation becomes equal to this, right? Because if this h over here is equal to 0 and this k over here is equal to 0, you eventually end up with this equation. Now let's see what the equation of a circle is using the endpoints of its diameter. So let's say that A and B are the endpoints of the diameter of a circle, right? So again, let's draw the coordinate axis, x-axis, this is the y-axis, and let's say that you have this as the center of the circle, and let's say this is the circle, forgive my drawing, and let's say you pick this point over here as A, and let's say you pick this point over here as B. And so if you draw, if you draw a line from A to B, it cuts the circle into two equal halves, And so this is the diameter of the circle, right? And as you know that the diameter is 2 times the radius. Okay, so this is the diameter of the circle, and let's say that the point P is a point on the circle such that the angle from A to P and from P to B is 90 degrees. Okay, so let's say that this is the point P. So if you draw the triangle APB, this is 90 degrees. Okay, so now that that's covered, we know now that the line A to P and the line B to P are perpendicular to each other, right? And as you know, the formula that when two lines are perpendicular to each other, then the product of the gradient of the first line and the second line is equal to -1. So the slope of AP and the slope of BP, slope is also called the gradient, this is equal to -1. So now you write down the formulas for the slopes of both lines, right? Now the slope of AP is basically equal to the y value of point P, right, minus the y value of point A over the x value of point P minus the x value of point A. Same goes for the slope of the line BP, that is the y value of point P again, minus the y value of point B over the x value of point P minus the x value of point B. Now the product is equal to -1. Now that you have this, all you need to do is now you need to multiply the denominator of the left hand side with the numerator of the right hand side. Since -1 only, since this is just a whole number, you just multiply the denominator of the left hand side with -1 on the right hand side. So you get this, right? Now you take what's on the left hand side, what's on the right hand side to the left hand side. So this becomes this on the left hand side, and you're just left with a 0 on the right hand side. And this is the required equation of the circle with the endpoints of diameter A and B. Now let's see how we can form the general form of the equation of a circle with its center and radius, right? Now you remember the general equation. We've discussed this before. It's something like this: x minus h whole square plus y minus I whole square is equal to r square, right? Where the point on the circle has coordinates x and y, and the center of the circle has the coordinates h and I, right? And r is the radius of the circle. But you can see this is also the equation of a circle. But we need to now convert this into the general form of a circle, which is this one over here, right? And we need to determine what the center of the circle is and what the radius is, right? So from this, we already basically know that x and y are the points on the circle, but we still do not know how to determine the center and the radius. So what do we do now? First, we add g squared plus f squared on both the left hand side and the right hand side of the equation. So you get this. Now what you need to do is you need to simplify this. So the first thing you do is you take this constant term plus c to the right hand side, and it becomes -c. And then what you must do is the remaining terms on the left hand side, these terms, you need to consolidate them, right? So we get this by consolidation. How have we gotten this? Well, you know that x plus g whole square is equal to x squared plus 2gx plus g square upon expansion. And that's exactly the three terms you have over here, right? So you can consolidate these three terms into x plus g whole square, and the remaining three terms, this y squared plus 2fi plus f square, you can use the same logic and you can consolidate it into y plus f whole square, right? So now you have this. Now what you must do is, since you know that in the general form you have negative signs, right? Let me just again write this down. This is the general form of the equation of a circle, and you see these are negative signs. So now you need to, instead of writing x plus g whole square, you write x minus negative g whole square and y minus negative f whole square, right? And again, since the term on the right hand side is a square term, r square, so you need to now basically convert this term on the right hand side into a square form. So what you do is simply you put this put the entire right hand side in an under root sign and take the square of that, right? So that the actual value still remains as it did before, right? Because eventually this square term and this under root sign, they both cancel out, and they give you the same g squared plus f squared minus c. Now you have this, and from this, if you remember the equation, the general equation, which was this, right? This h corresponds to this negative g, and this I corresponds to this negative f, and this r corresponds to this under root g square plus f square minus c, right? So minus g and f is the center of the circle, the coordinates of the center, and this term under root, this term inside the bracket, which is this one over here, g square plus f square minus c, this is the radius of the circle, right? Now let's see the equation of a tangent and a normal to the circle. Now, before we dive into this, let me just explain what the tangent and the normal are. So if you draw the coordinate axis, right, y-axis and x-axis, and let's say this is the center of the circle and this is the circle itself, right? And it says that you have this point over here, right? And it says that you have to find the tangent at this point. Then what you have to do is you look at this point and you draw a very sleek line, a straight line. I'm sorry for my art, but yeah, this is a straight line that basically gives you the gradient of the circle at that point, right? So if you took this point over here, right, let's say they ask you to find the tangent at this point, you would draw a line that just touches the circle at that point, and that will give you the gradient of the circle at that point, right? And let's say you have this point, the gradient, the tangent would be like this, and you get the idea, right? And so let's say they told you to find the normal to the circle at let's say this point over here. The normal would be perpendicular to the tangent, so it would be something like this. This would be the normal, right? It's perpendicular. The normal at this point would be something like this, 90 degrees. The normal at this point would be something like this, right? And you may have noticed something. All the normals to the tangents of a circle eventually end up coinciding with the center of the circle. So the normals are technically the radii, right? But the only difference is it's not just limited to the circle, because this line is also perpendicular to the tangent. If you extend the line backwards, this line is also perpendicular to the tangent. If you extend this line, it is also perpendicular to the tangent. But yeah, eventually they all end up at the center. So now that you've covered what the tangent and the normal to the circle are, let's see how you can find the equations for the normals and the tangents. So this is the equation of a circle, right? With its center at minus g minus f, right? This is the center, and any point on the circle being x and y. Okay. Now, the equation of the tangent, let's say at an arbitrary x1 and y1 coordinate, well, let's see. This equation will be this. Okay. So, for example, again, let's just draw a circle, right? It's in the coordinate axis. That's just a given. But let's say this is the point, and let's say the coordinates are x1 and y1. And they told you to find the equation of the tangent at this point. So this line over here, you need to find the equation of this line. That can be given by this equation over here, right? So well, what you simply need to do is, let's say this x value is 8 and this y1 value is 11. So all you have to do is replace this 8 in over here and over here, right? And you replace this 11 in the y1 placeholders, so over here and over here. So eventually you'll get the equation of the tangent. And also, let's see how you can find the equation of the normal at this same point, x1, y1. Well, you use this formula, and if you cross multiply, you eventually end up with this, right? Y minus y1 over, if you take this to the denominator on the left hand side, x minus x1 is equal to y1 plus f over this x1 plus g, right? So both of these are equivalent, and you can use this equation to find the normal at this point. So basically this line over here, right, as it's normal to the tangent. Now let's see the definition of a chord, the definition of diameter, and what a perpendicular line from the center of a circle and its importance in the geometry of a circle. So let's see what a chord and the diameter of a circle are. Now, a line segment whose endpoints lie on a circle is called the chord. It's called a chord of the circle. And the diameter of a circle is a chord containing the center of the circle, right? So what you have over here, this line running from A to B, this is the diameter of a circle. So let's say you took other 2 points. Let's say you took this point over here, right? So let's say this is point C and this is point D, right? And if you draw a line connecting these two, you can see that it does not contain the center of the circle, right? Which is this point O over here, right? But if you extend this C down to A and this D down to B, it will contain the center of the circle. So CD, this line CD is a chord, yet the line AB is a chord, but it's also the diameter of the circle, right? Because it contains this point, the center of the circle. Okay, now that that's cleared up, let's see what the perpendicular line from a circle is. Now, it says that the perpendicular dropped from the center of a circle on a chord bisects the chord. Bisection means that separation into two equal lengths or halves. Okay, so what that means is, you can see the circle over here, right? If you draw this chord over here that runs from this point A to this point B, and then you look at the center of the circle, which is this point O, if you draw a line that runs from this center to the chord, it bisects the chord. So basically, this part of the line, this half of the line and this half of the line are both equal, right? So let's just take an example on this bigger circle over here. Let's say you have this chord over here. Let's just take this one, CD, right? Now, if you draw a line that goes from the center to the chord, right? And it must be perpendicular to the chord, right? So this is 90 degrees. Then this half and this half are both equal. And just to make it very, very clear to you, because this is very important for later calculations, if you took this chord over here, right, and you took a line perpendicular and took it to the center, right, then this half and this half both are equal. This is bisection. Now let's see what a parabola is. So I know most of you know what a parabola is, right? Because we've studied quadratic equations many times before. Well, let's see it in a more formal way right now, the geometric way. So a parabola is a curve in which every point on the curve is equidistant from a point called a focus and a straight line called a directrix. Now let's see what a directrix is first. A directrix is any line that is parallel to the x-axis, right? Now let's say you draw this line over here parallel to the x-axis, right? This is the directrix. Now the focus is a point that is equidistant from the directrix and the extreme point of this curve. Now the extreme point on this curve is this point over here, right? As it's the absolute bottom of this curve. Now you calculate the distance from this point to the directrix, and you draw a point directly above this of the same distance. You draw a point above the extreme point directly in the same length as the distance from this minimum point to the directrix. Now let's say this length is x, right? So you draw a point with the same length over here, okay? Let's say it's this point over here. This point also has a length of x. Now what you need to do is you need to see that if you take any point on this curve, let's say it's this point over here, right? This point will have the same length from the directrix and this point that we took before. Both of these points are equal, right? So let's say this is length f, so this will also be length f. Now let's say you take another point on the curve. Let's say you take this point, right? You draw a line from this point to that point, and then you draw a point from that point down to the directrix, right? Both of these lengths are equal in a parabola. Let's say this is length g, and this will also be length g. Now this is what you call a complete definition geometrically of a parabola, right? This point that you took is called the focus, and this line that you drew is called the directrix. Okay, now we already know that a parabola is always a u-shaped curve. You can have this u, or you can have a u like this as well, right? It depends on the equation. And it will always have a vertex and an axis of symmetry. Now the line that we were drawing the focus on, right, is the axis of symmetry. Basically, the axis of symmetry divides the parabola into two congruent pieces. So this, in this particular case, is the y-axis. It divides it into the congruent pieces, this piece and this piece. They're both identical and they have the axis of symmetry as the y-axis, and the vertex is the extreme point. We took this as the extreme point, remember, in this particular case, and in the case above this case, this will be the extreme point, right? It's very intuitive. You know what an extreme point is, right? Now let's see what an ellipse is and its elements. So an ellipse has 5 elements. It has 2 foci, a center, a major axis, and a minor axis, right? So what does this mean? Well, this is what an ellipse looks like. Now, why does it have 2 foci instead of one focus as in a parabola? Well, I found out a very interesting reason for why it has 2 foci. Look at this shape. It's almost like you've joined 2 parabolas together, right? One is this parabola, right? And the other is this parabola. Now, these are 2 identical parabolas, just inverted from one another, and they're joined together to form this weird oval shape called an ellipse. Now, this focus F1 is the focus of the left parabola. Well, I wouldn't call it a parabola, it's like an inverted parabola, right? And this F2 is the focus of this second parabola, right? Second inverted parabola. So this is why it has 2 foci. Now, it has a center, obviously, because, well, it's an oval shape and it will have a center like a circle. And it will have a major axis, which is, as you can see in an oval, it has one side that is longer and one side that is shorter. The axis that divides this ellipse into 2 equal long halves, like this half and this half, this axis, right, this is called the major axis. And the axis that divides it, well, let me just change color to explain it better. Wait just a second. Okay, the axis that divides it into this half and this half, this axis is called the minor axis. And yeah, that's really all you need to know about ellipse. And just remember, 2 foci corresponding to 2 parabolas, if you will, right, that are joined together, a center as it's an oval shape, a major axis, the axis that runs along the longer side of the parabola, and a minor axis that runs along the shorter side of the sorry, not the parabola, the ellipse. The major axis along the longer side of the ellipse, and the shorter side along the that runs along the shorter side of the ellipse. Now, an ellipse can be like this as well, right? In which case the major axis would be this axis and the minor axis would be this axis, right? So I hope that clears things up. Now let's see what the standard form of an ellipse is and its explanation. Now we need an equation for an ellipse, right? The standard equation of an ellipse is this, right? Now x and y are just, as in the case of circles, parabolas, they're just placeholders for any points on the ellipse. But what are A and B? Well, let me just first draw an ellipse for you. Let's say this is the coordinate axis, right? And let's say that this here is an ellipse. Let's say it's centered at the origin O, right? So 0, 0. It's centered at this point. Now, basically, this equation that is given to us is indeed for an ellipse that is centered at the origin. So we can apply this equation on this particular ellipse, right? Just cut out this part over here. Now, A is the distance from the center to the horizontal vertices, right? So again, what are vertices? vertices are extreme points. The extreme points. So the horizontal vertices are these 2 points that are the absolute maximum points on the horizontal axis, right, that touch the ellipse. And B is the distance from the center to the vertical vertices. Now the vertical vertices are these extreme points on the vertical axis, right? So A is this distance and B is this distance or this distance, right? Because they're both equal, and similarly this is also equal to A. Now, if A is greater than B, then the ellipse is stretched horizontally, as in this case. You can see that indeed this distance A is greater than this distance B. So it is stretched horizontally. Whereas if B is greater than A, well, you would have something like this. This would be your ellipse. Don't mind my drawing, but it's basically an oval, right? So you can see that B is the distance from the center to the vertical vertices. So these are the vertical vertices over here. And as you can see, this length is greater than this length, which is A. So this is stretched vertically instead of horizontally. So I hope that clears up how you can use this equation to define what how the shape of the ellipse will be, right? You just look at these 2 terms over here and you can see if the ellipse is stretched horizontally or if the ellipse is stretched vertically, and you can also determine the distance that the elongation is from the center of the ellipse, which is the origin. Now let's see what a hyperbola is. Okay, this is what a hyperbola looks like, right? And you can see that it's similar to an ellipse. It's basically an inverted ellipse, right? It's similar to an ellipse. It's comprised of 2 parabolas. One is this one, and the other is this one, right? The only difference is that both of these parabolas are inverted, right? So hence I gave it the name an inverted ellipse. It's similar to an ellipse also because it has 2 foci, right? And it has this equation that holds true for all hyperbolas. Now in case of an ellipse, this equation was f1p plus f2p is equal to some constant. The only difference between both of these equations is this sign, and it exists because of the inversion of the parabolas. Now again, this equation, what does it mean? Well, if you subtract this distance from this distance, it will always be a constant in case of a hyperbola, right? So if you take any point on this hyperbola, this equation will hold true. Now let's dive deeper into the equation of a hyperbola. Now these are 2 possible cases. Similar to an ellipse, which also had 2 possible cases, this has 2 possible cases as well, right? Now let's take the first one as an example, and all of the rules over here will apply to the second one as well. Now you see this equation. Well, here's the thing. You can see that this A over here, that's just the distance from the center to the vertex, right? And by the way, both the distances are the same, right? Because hyperbolas are symmetrical, as in the case of an ellipse. So we'll just take this parabola as an example here first. Now, this A is the distance from the center to the vertex, okay? Now, this C over here,
right? That's basically just the distance from the center to the foci. Sorry, the focus. Foci is plural. The focus, any one of these focus. Okay, and basically A, again, the distance from the center to the vertex. C is the distance from the center to the focus. What is B? Well, here's the thing. B will lie on in this axis, right? And this is B. Basically, you have a formula. C square is equal to A square plus B square. So C is equal to under root A square, A square plus B square. So what that means is that, let me just clear this up. It means that this is the distance B, right? This is the distance A, right? And this is the distance C, okay? And basically, B would be, well, B is equal to C square minus A square whole under root. And you can calculate this distance now. And since once you have this distance, you can just simply apply this formula in case of this type of ellipse. If the axis of symmetry, which in this case is the y-axis, if the axis of symmetry of the hyperbola is the x-axis, which is in this case, you'll have this equation, right? And yeah, that's really about it for a hyperbola. And I hope this is understandable to you. Just remember this equation, right? C is the distance from the center to the focus. A is the distance from the center to the vertex. And once you have those, you can calculate what B is. Okay? And once you have B, you can apply this formula, or in this case, this formula. And yeah, that's about it. Now let's discuss the definitions and equations of tangents and normals. Okay, the definitions first. A tangent is a straight line that touches a curve at a single point, and a normal is a straight line that is perpendicular to that tangent. So, for example, if you have this point over here, right, this line, this tangent line just touches this point and then goes down, right? It starts here, it just touches that point and it goes down. Okay, obviously I cannot draw that well, but you get the point. Okay, and the normal is the line at that point that is perpendicular to the tangent. So this is a 90-degree angle, right? Okay, now that that's cleared up, let's just see what else we have. Now the equation of the tangent. How do you find the equation of this line? Well, this y naught is basically the y value at that point, right? So it's this y value, this is y naught, and this x naught is the x value at that point. So this is x naught, right? Okay, you can just insert those values in, but what is this? This is the derivative of the curve that you're taking the tangent on. Now the curve we have over here is a parabola, right? This parabola over here. And the first thing you need to do is find the derivative. Let's say that the equation of this parabola is f of x is equal to x square plus, not x square, let me just make it a little bit more difficult. Let's say it's 2x square plus 3x plus 4. Now the derivative of this equation would be 2x raised to the power 2 minus 1 into this power, so 2, right, plus 3x raised to the power 1 minus 1, you just subtract 1 from all the powers of x, into this power again, the power of x over here, which is 1, right? So into 1, plus 0. A constant becomes a 0 in case of a derivative, okay, because it has no variable with it. Okay, so this results in 4x plus 3. This is the equation of the derivative of this parabola, and then you insert the x value of that point, so this x value, right, into this equation. So that would be 4 into whatever you have as your x value plus 3. And once you have that, you have the complete equation of the tangent in terms of this y and this x. Now the equation of the normal is obviously you just take the negative reciprocal of the gradient you found over here, which is f prime of x naught, right? And the rest remains the same. So you have this as your equation of the normal at this particular point, or any point really, just that the y naught and x naught values change. But these are the ways to find the equations of the tangents and the normals. Now let's see what the translation of axis is, and let's discuss its equations. So basically, if you had an original axis with lowercase y y-axis and lowercase x x-axis, and you translated the whole axis to a new position, right? So obviously its origin would no longer be at 0 and 0, it will be at some other one. So let's say you had this original axis and this was your new axis, right? So the origin would be shifted to points, let's say h and k, right? So basically this would be h and this would be k. Okay, well, now that you have your new origin, you have your new axis as well. And these will obviously, the new y-axis would be parallel to the old y-axis, and the new x-axis would be parallel to the old x-axis. But now let's discuss the equations. So these are the equations of transformation, right? So basically what this means is, if you had, say, this point over here, say according to the new axis, it's at 3 on the x-axis and 3 on the new y-axis, but you needed to find its value in the old axis, right? So you need to find this value and you need to find this value. How would you do it? Well, simple. Basically, you'll use these two equations. So you need to find the value of this point in the old axis. So the x value would be x is equal to the new x value, which is 3, plus h, which let's say in this case is 4. Let's say the h value is 4 and let's say the k value is 3. So x, the position of this point in the old axis would be x is equal to 3 plus h, so 3 plus 4, which is 7. And its y value would be again 3 plus k, which is also 3, so 6. So this point x here is 7 and this point y here is 6, and so this has the value of this point, the coordinates of this point in the old axis would be 7, 6, and that's really about it. Now let's discuss the rotation of axis and its equations. Before we discuss translation, now let's discuss rotation. So it says that if, say, this was your original axis, right? Let's say this was your original axis, right? With lowercase y-axis and lowercase x-axis. And now you've rotated this entire axis by a degree theta. Let's say this is the degree theta, right? You rotated this entire axis, so now you have a new axis with this new y-axis called y prime axis and this new x-axis called x prime axis, right? Now let's say you needed to find the coordinates of a point that are given to you according to this new axis, right? And you needed to find its coordinates in the old axis. what would you do? Let's say you have this point over here, right? And let's say its coordinates are given to you in the new axis with, let's say it has a value of x, the new x value as q, right? And a new y value, let me just be very careful with this value, let's say that's L, okay? And you need to find its value in the in the old axis. That would be over here. Let's say that value is, let's just call it y, and let's call its x value as m, right? So the equation for that is this. You need to find the x value of this point in the old axis, in the original axis. So what you would do is you would take the new x value, which is in this case q, right? So q cos theta, the angle that you have translated the whole axis with, minus the new y value, which in this case is L, right? So L, sine of the same angle, theta, this one. And this will give you the x value in the old axis, which in this case is m, right? Now you need the old y value. Simply, you multiply the x value of the new axis, which is q, right? This one over here, and you add to that. You multiply it with sine theta first, right? So the sine of the same angle theta, and you add to that basically the product of y, the new y, which is L over here, into cosine of the same angle theta, and that will give you the new y value, which we give the name as y, the old y value, the original, the value of this point in the original axis, right? So these equations will give you the value of a point in a translated axis in the original axis. You were given the coordinates q and L, and now you have the coordinates m and y. Now let's discuss how you can classify the nature of conics by discriminants. So basically you have this as your general equation of any conic, right? I think you remember this from the circles. And basically you can determine if such an equation is given to you, and you have to determine whether it's a parabola, a circle, an ellipse, or a hyperbola. You need something easier to do than to just draw this entire thing out. In that case, you use this thing, the discriminant. Basically, it's h square minus ab. That will be the discriminant. And this h is basically this one, this a is this one, and this b is this one. Once you have these values from the general equation, you can determine if it's a parabola, a circle, an ellipse, or a hyperbola. Basically, if the ellipse is less than 0, right? If the determinant is less than 0, it's either an ellipse or a circle. Now, if you need to determine between an ellipse and a circle, that's a more complicated matter. And you can just do that by plotting them out, or basically, the equation of a circle and an ellipse are very different. I think it's a bit simpler than I said previously, right? And if the discriminant is equal to 0, it's a parabola. If the discriminant is greater than 0, it's a hyperbola. Now, let's take an example. So, for example, if you have 2x squared plus, let's say, 6y plus 8y squared plus, let's say, 2g, sorry, not g is a constant, 2x plus 10y plus 9 is equal to 0. Let's say this is your general equation, right, of the conic. And now you need to determine whether it's an ellipse, a circle, parabola, or a hyperbola. Well, you just find the discriminant first, h squared minus ab. What is h? Well, you can find h by this. So 6y is equal to 2 into 3 into y. So this 3 is your h, since 2hy. 6y is equal to 2hy, so 2 into 3 into y, and h is 3. Now h is equal to 3. Okay, what is a? A is simply 2 in this case. So a is equal to 2. Now what is b? By squared, so 8, right? So b is equal to 8. Now let's find the discriminant. The discriminant is 8 square, so 3 square minus a into b minus 2 into 8. So this is 9 minus 16, which is equal to minus 7. And minus 7 is less than 0. So it's either an ellipse or a circle, right? So in this particular example, it's either an ellipse or a circle.